Alright, so let's solve this system using the addition method. So step 1 says to rewrite both equations in the form of ax plus by equals c. Well, they're both already in that form, aren't they? So step 1 was already done for us. So I'm just going to put a check mark or write done. It was already done. Okay? Step 2 says if necessary, we're going to multiply either equation or both equations by appropriate numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. Alright, so yours is on the same page. You can see it above. Mine is not. So I'm going to rewrite this here. So here are my two equations. And so I need to decide, do I want to get rid of the x or the y? Now, some things that I use to help me, okay? If they have the same coefficients, like if both of my x's had the same number, then I choose them. Or if both the y's had the same number, I would choose it, especially if one's positive, one's negative already. If not, it's easy to multiply to make that happen. The next way that I do, if that's not available, then do I have an x or y that one is already positive and one is already negative? If so, I choose it, because then I don't have to worry about my signs. But honestly, it really doesn't matter which one you choose. Neither one is really hard to get rid of. There's just a few things that make it a little bit easier. So do we want to eliminate or get rid of our x's or our y's? Our y's. All right, so now the way I'm going to show you is not always going to give me the smallest of numbers, but it'll work every time, okay? So the number that is the coefficient of the y in the first equation is what I'm going to multiply the second equation by. I don't worry about the sign of it, whether it was positive or negative. I'm just going to do the digit, okay? So because I had a 5y in the first equation, I'm going to multiply the second one by that 5. The second equation, we had a 3y. So I'm going to multiply the first equation by that 3. Now look in your original equations right here. Is one of those positive and one of them negative for the y's? Yes. If not, if they were the same sign, I would just have to make one of my numbers on the outside negative. It wouldn't matter which one. So now we're going to take this number on the outside and we're going to distribute it all the way through its parenthesis. So this first one's going to give us 12x plus 15y equals 9. And we're going to do the same thing to the second, bless you, equation there. We're going to distribute that 5 all the way through it. So that's going to give us 10x minus 15y equals 35. And then we're going to combine those equations together. So this is why it's addition, because we're actually adding them. So then what is 12x plus 10x? What is 15y minus 15y? That's what we wanted, right? All right, equals, what's 9 plus 35? 44. Okay, so I actually jumped ahead a little bit here. What we just did is our step 3. Okay? Because step 3 said to add the equations. And now what we're about to do here is step 4, which says solve the equation in one variable. So let's solve. How? Divide by the 22. And so we get that x equals 2, right? All right. So that is the x variable of my solution. All right, so since we went ahead and we did step 3 and step 4 on the same as the slide of step 2, I went ahead and jumped over here to step 5, which says use back substitute and find the value for the other variable. So remember our two equations we had are what? 4x, it's really big, plus 5y equals 3. And 2x minus 3y equals 7. And we said that x was 2, correct? So to back substitute to find the value for the other variable, we're just going to pick one of those equations and we're going to plug 2 into it. So which equation do you want to use, the top or the bottom? All right. So you chose the top one. So 4x plus 5y equals 3. And so we're going to plug in that x is 2.
Is y 2?
No, just the x, because we're going to solve for y. And then I work this out. So 4 times 2 is, I'm going to bring down my plus 5y equals 3. Now what do I do? Subtract the 8. So 5y equals negative 5. And then divide by 5, and we get y equals. So we believe our answer is going to be what? 2, negative 1. But remember, we still have step 6, which tells us we're going to check it. Alright, so step 6 is to check it. So we have to check it in both equations, right? So our equations are 4x plus 5y equals 3. And 2x minus 3y equals 7. And what are we checking again? What did we think our solution is? 2, negative 1. So we're going to plug that in for our x and our y. So I'm going to check my first equation. So 4x plus 5y, and we want to know, is that equal to 3? So we're going to plug in 2 and negative 1. And then we're going to solve. Remember, when you're checking it, you only work each side individually, okay? So 4 times 2 is 8. 5 times negative 1 is, and 8 minus 5 is, which is what we wanted, right? So let's do the same thing in the second equation. So 2x minus 3y, and we want to know, is that equal to 7? So plug in your x is 2, your y is negative 1. Alright, so then we're going to do 2 times 2, which is
4.
negative 3 times negative 1.
Negative or positive 3.
And 4 plus 3 is,
7.
which is what we were looking for, right? So we know for sure that 2, negative 1 is our solution.